This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. Hi, I'm Lee Bortons, and it's Wednesday, February 7th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss 2 lessons each week from our soon-to-be-released math curriculum for families with students in classical conversations communities. Kirsty, we're already at 9 and 10. I'm pretty excited about today.
It's going by very quickly, doing 2 a week. So, and we are in a new dimension. So we've been we made it through 0D in 1 week, and then we spent 4 weeks, well, I guess 3 weeks in 1D, and now we're going to spend several weeks 2D. And I oftentimes think that what we talk about in our 2D lessons feels perhaps the most mathy that a lot of us remember, where we're talking about geometry and functions. So it's going to be, I think, a lot of fun to unpack that at a 6-year-old level. And really take some of the take a few steps back from, hey, what do you remember about this, and really look at what the grammar and the big ideas of those topics are. So before we jump in, does anybody have any lingering questions that they need to ask before we start with lesson 9? All right. So we're going to jump into lesson 9 straight.
Wait. I have a question. I don't think anybody's asked this. At the top of this math map, what's the A and then the AC?
So so where we have our N, Z, Q, R, C, A, and AC, sounds like an eye chart, doesn't it? Those are very standardized across the math world. No abbreviations or notations that represent entire number sets. And so we may be more familiar with N for naturals, Z for integers, Q for rationals, R for reals, and C for complex. When we look at our challenge B and above domains, we're talking about algebraic numbers. And so we're going to look at numbers that are solutions to polynomials, and those are defined as algebraic numbers. And then all the numbers that are not algebraic are that's the complement. That's what that C stands for, is all the numbers that are not algebraic. And we're going to be looking there at transcendentals. And so we're going to be not just looking at really the biggest number set. There's more transcendental numbers than there are algebraic numbers. But we're going to be also considering the spiritual transcendentals of truth, beauty, and goodness. So we're going to be talking about that with our smallest students in digits all the way through, but our goal is really that our challenge 4 students are going to be confident working with odd numbers. And when I say odd, I mean numbers that are not familiar, so really unfamiliar numbers, as well as looking for God in the midst of that, and looking for how we can discover more about truth, beauty, and goodness through mathematics. And so that's really there to remind us of what our end goal is through the math map and through the years of being in classical conversations community.
Thanks.
All right, so lesson 9 is straight lines. It is our introduction to 2D. And so let's go ahead and take a look and see, now we're in a new dimension, what things are still familiar here. Think too about the curriculum as well as the math that you see, what is familiar, and then maybe what's new, what is unfamiliar to you.
The sections are the same. Pages are laid out the same way.
And there's always a grid of some kind at the top.
It's familiar to trace, so even if I don't know where to begin, I know that I just begin to trace and read and trace and just kind of except that I'm loading grammar into my mind instead of having to understand it.
So like the instructions are familiar because we see the same type of instructions every week.
The rabbit and hopping is familiar.
What are some things that are unfamiliar? Is there anything on there that makes somebody go, not sure about that?
Having
That-
the rabbit's journey in 2 stages is unfamiliar. So if you remember how to graph, I would hop over 4 and up 6.
Okay.
The A plus BI is new.
We're seeing our sentence, but it's changed a little from a line is that which has length but no width and height. Now we have a plane using similar descriptive words.
Right. So some of the patterns that we're saying, we may notice our first time through the math map. For example, we may notice that, hey, I've still got these bars that are dividing my page up. That feels really familiar to me. We may recognize that there's some kind of a grid at the top of the page, and that feels familiar to me. It may take more than one dimensional shift or more than one time through the math map to recognize there's a lot of consistency in how these things are described. For example, defining a line or a plane. And then our real world, right? So being familiar with a bunny rabbit, and then saying, but if I was a bunny, I would just go straight there, right? So or have you watched a bunny and maybe they don't actually go straight there? Maybe they hop all over the place and this looks more familiar, right? So there's a lot of things that we can discuss as far as what's familiar and unfamiliar. So let's take a minute and recognize that we are in a new dimension. And so Lee just read that about a plane. So what is a plane? If you had to use your own words to describe or define a plane, what is a plane? Because that is a new idea. That is a 2D idea, not a 1D idea.
It appear to say it's an infinite shape.
Okay.
I'd say it has a length and a width.
I think of a plane as a flat surface,
Mhm.
like a piece of paper.
You can now have horizontal lines at the same time you have vertical lines and oblique lines.
Is it easy? And when I say easy, I'm putting quotes around that, right? So using Kathy's illustration of a plane, using a piece of paper for our students, right? So we might say the piece of paper that your lesson is on, right, is a plane. It's flat. Can we help them to think, what if that goes on infinitely in every direction?
I think we can help. I don't think any of us can truly stretch our imaginations that far, but if we maybe got a roll of wrapping paper, that nobody likes anymore, nobody's using, it's just still taking up space. You could flip that out and talk about, and it rolls out. And what if it went on forever and also in this direction and also in this direction, that might be one way to give them the idea that it is so much more than just one piece of paper, even though we're just looking at a part of it.
Good.
I think another good example to use is a shadow, because a shadow of a building could be massive and the shadow of a twig could be very small. And I'll issue a challenge here. So far, a shadow is the only two-dimensional shape I can think of that exists in three-dimensional space. So if anybody can come up with other ones in the next few weeks, I would love to hear it. Because a shadow only goes left and right. It doesn't have a bottom.
So one of the reasons why I asked you that idea about being able to picture the infinity, the infiniteness of a plane is just to hold that idea, right? Introduce that idea now, because we're going to talk about what that looks like in 3D and in 4D. Because one of the things that we can do when we're thinking about 1D or 2D is we can be outside of it. So it's a little bit easier to, for example, look at your computer screen and say, well, there's my plane, and it goes infinitely this way and infinitely this way, right? And so just hold that idea, because we can circle back around in that in a few weeks' time. So I just wanted to give you that challenge. So let's take a look at our page 1 here, and notice we use a word frequently called coordinate, right? We see there's several places on here where we see coordinates. And look at that middle right box. And what are the 2D coordinates? Does anybody want to hazard a guess as to what the 2D coordinates, we might name them, or how many there are? What are some things from this page that we might say to describe what coordinates are in 2D?
Well, I see X and Y, so
That's what I was about to say.
yeah, 2 different directions.
Now, there's a case where that might be familiar to us as parents and less to our students, right? So, and that's okay. It is okay for there to be things that are familiar to you, if not for your.
I could see a student, a little kid, thinking of the alphabet and thinking of a line X, Y, Z. So that's a pretty new concept for them.
Mhm.
Well, since this is just one quadrant of the plane, the coordinate system, then you could say right and up.
Good, I like that. If we were to do the other quadrants, Melba, how might we describe that?
Left and up, or left and down, right and down.
That's great. So with our students, right, some of this, right, so we want them to say, okay, I've got, I might use these symbols X and Y, or theta and R, or A and BI. I may use some of these things these symbols I'm becoming familiar with. But with our younger students, sometimes helping them to just build their memoria and their understanding maybe is exactly what you just did, right? Because they're maybe familiar with left and right and up and down. And that gives us some language that we can use with them that's still good mathematical language, but also more approachable, and is giving us that's the familiar that now we can build onto with the unfamiliar. Because I might say, oh, when we talk about X, I'm talking about whether I'm going left. And when I talk about Y, I'm talking about whether I'm going up or down, right? So that's when we talk about familiar and unfamiliar, that's exactly what we're trying to do. It's a great job. All right, let's take a look at page 2. And I'm going to skip over familiar and unfamiliar on this page. And instead, I'm going to encourage you to take a look at the page. And then how would you describe these different slopes? So I went ahead and pulled these off of here, and there's some things on here. There's positive, and negative, and 0, and infinite. We also have the words horizontal, oblique, and vertical, or downward and upward. So how could you take those ideas and put them together to describe these slopes?
I really like the ants. I think that's a great place to start, with the downward, upward, no slope, and all slope.
So which one's positive, Jill?
Going uphill would be positive. I'd be working harder and having to put out more energy and going in a higher number up. And if I'm going downhill, my number is decreasing in altitude, at least. Although I realize this isn't altitude, but it, you know, maybe going up and down on the slide. How many steps up do you have to go? And then you slide down outside.
Good. What is an inherent idea? So now I'm going to just challenge you all. This is not something you would do with your 6-year-olds, but when we think of going up and down and the slope, what direction are we thinking of our movement being? In addition to up and down, what other direction are we thinking?
We're thinking left to right.
Yep, we're thinking left to right. And so that's a kind of a big idea, right? When we think about describing graphs that we sometimes take for granted, but here is a chance to help our students see we're always kind of going left to right. We're always moving forward when we describe whether we're going up or down. Right. And so that positive slope and negative slope is always based on if I'm going forward, am I going up or down? Right. So how about zero slope and infinite slope? Which one would be better for riding a bike?
It depends on if you're training or not. Usually I would want just horizontal, but I ought to want some oblique climb.
Or perhaps if you're at a Cirque du Soleil, right, when those guys ride straight up the wall. So
that's pretty amazing. I think one of the reasons Kirsty's spending so much time on slope, and I did too in writing the curriculum, is that I found when we first started designing it, like I could do the calculations in a 2-dimensional function equation, but I couldn't see where it lived in space. And so once again, you know, the understanding then got limited, versus what we're trying to do now is just harp over and over again on these kind of lines and where they live and how they are in relationship to each other, so that then as we slowly attach points to them and equations to them, they have a sense of these words first.
anything else you would like to share about this page where we're looking at these linear graphs? All right, let's look at page 3. And here we're being told that we're looking at graphs and inequalities. And so let's look at that top box there and those dashed lines. And when use each one.
I think that having inequalities in the math map geometrically has been one of my repeating aha moments, because my whole life growing up, inequalities only meant two numbers greater than, less than, or two equations greater than, less than, and really not this kind of dashed line. So I think that I'm still growing in how to articulate that, especially with younger kids. With older kids, I kind of understand, you know, what do I do? But with younger kids, to say it's everything below the line but not the line, I think is, I mean, it can really be that simple. But sometimes for parents, we feel like we have to say it again and again, lots of different ways till we see little like flickers going on. If we don't see flickers, we just keep talking.
Yeah. So Kirsty, maybe help where I was struggling a few months ago with the difference between, so open, closed, dashed, and solid are really just descriptions of the shape in front of you. But when they're talking about being inclusive or bounded, like the abstractions that they're representing, do you have ideas on how to make that easier?
Well, it's what, Jill just did a great job of saying it can be, if we were talking about less than, right, strictly less than. So strictly is a word that helps us to describe whether it's just one thing or whether it's possibly two things. So if we had that we are less than, strictly less than, then it's everything below the line or above the line, whichever, right, less than would be below, just below the line, but not including that line. Whereas if I said an or equal to, now it's not strict because I have an or, I have two options that I can either be below that line or I can actually be on that line, right? And we use those ideas of open and closed to describe, right? Can I kind of get in, right? Does it form this solid boundary or not? That is maybe the imagery that we're thinking of, right? A solid line has this idea that it's closed off, right? It closes off that piece, where the dashed line gives you that sense that maybe it's open in somehow. Just like a circle, whether my circle's closed in or whether my circle is open. And so that then is giving us an idea about whether or not what we're doing is inclusive of our point or inclusive of our line, or exclusive of our point or exclusive of our line. So there's all these different words that we use to talk about the same idea about whether or not a specific line or point is included in our solution. So I was just going to challenge everybody to think, can you think of any real life scenarios where something could be less than but not equal to?
Yeah, I was thinking of a picture that some of our leaders are at the Panama Leadership Forum with our Spanish speaking countries today. And our editor posted a picture of a cat sitting on the wall underneath a sign that says in Spanish, "Don't walk on the wall," which is cat behavior. But the cat could have walked anywhere up to the wall. Where he transgressed was walking on the wall. So that would be like our line. And we've all done that with our kids. Like, you can go this far in the neighborhood, and inevitably there's one kid in the family that puts their toe on the line and turns around to look at you. And you're like, no, that was not included in the permissions. Get your toes back on this side of the line.
Love it.
I was thinking being told not to touch something, and sometimes they'll get as close as they can to look at something, but you can get as close as you want, but don't touch.
That's great.
I just texted our designer. We're going to add that cat to this problem.
I'll send you the picture from Charity.
So mathematically, this is a really big idea because practically speaking, right, there's some limit to how close I can get to something, right? I mean, we may, right, our 3D-ness, just the thickness of our hands, means that at some point I'm going to be touching something, right? I can't get infinitely close because for all intents and purposes, I'm going to be touching it. But mathematically, I can keep getting closer and closer and closer and closer, right? And so that mathematical idea of having a bound to something, right? How far can I go? But I can't actually be that, but I can keep getting closer. And that boundary is still there, is a big idea mathematically. And so we're introducing these ideas to help kids see, right? Mathematically, we're building this understanding of ideas. So, all right, let's look at page 4 from lesson 9. And let's take a couple of minutes and take a look and see what is familiar and what is unfamiliar on this page.
Vectors are my arch nemesis. No, just kidding. I feel like I learn a little bit more every time, but so they're kind of familiar, but like I don't know everything about vectors. But I remember the first time I saw them and I was like, whoa, what is that?
Babs, I don't think that's any different than struggling over like dashed lines versus solid lines and boundaries and things. It's just all unfamiliar, and eventually it's like, oh yeah, I don't know why that was so hard, but it was.
I challenged 4 students this year told me that the way they remember Vector is from the Despicable Me movies, where he says, "I'm Vector because I commit crimes with both direction and magnitude." For whatever reason, that works for them.
So on this page, we're looking at different things when we're talking about vectors. We're looking at their notation and comparing that to the notation for different shapes. And here we're just building familiarity with that notation. Right? As students get older, we can then compare and contrast what those shapes are compared to what a vector is. And we can talk about the differences between them, but we're going to look at the notations for them. Then we're going to talk about operations with vectors and laws with vectors. Now we haven't, if you have gone through all of the pages, or the naturals in lessons 3 through 8, really 2 through 8, you may go, I'm familiar with some of these ideas because we saw the notations of vectors in 1D, and we saw some operations with vectors in 1D, and we've talked about laws in 1D. And so what is different this time? Is there anybody who's seen that and maybe recognizes that some of this is familiar from 1D and can tell me what is different here in 2D? What makes it different being in 2D?
Well, if you remember the tops of the pages and on the page 4 set of all those previous lessons, there was always that vector bracket with 1 number inside of it. Now there can be 2 numbers.
And before we graphed vectors on the number line, if you look at the examples in the middle of the page, they now have an oblique direction.
Does that fit with other patterns that we've noticed of 1 coordinate in 1D and now 2 coordinates in 2D? So again, I wouldn't expect your 6-year-old necessarily to recognize that or to find those patterns, but there's a way that even looking at the 6-year-old domain for the math map, we can start challenging our older students to look for those mathematical patterns.
Something I do in the car a lot with the kids is math problems with grandkids. And I know that probably sounds funny, but it's not calculations. It's things like saying, if there's 1 number in a 1-dimensional vector, how many numbers are in a 2-dimensional vector? And then how many in a 1,487,056 vector, right? And just giving them crazy numbers, and they can answer it, and they're giggling while they do this kind of thing rather than resenting it.
All right, well, there's lesson 9 and our introduction to 2D. And so let's just take a minute and here's our release schedule again, the materials that are going to be included with the digital versions and the print versions. And are there questions on this or anything else before we move into lesson 10? I'm going to go ahead and pause a moment and let you speak up.
In some ways, I think it's mean that we keep talking about the frames and the charts and the games and the things, then you don't get to see them. But on the other hand, I'm hoping it makes you go, I want to see them, so I'm going to buy the curriculum.
Yes, the question in the chat about the digits being deconnected sometime this year. Yes, those digital versions, the digits, the naturals, and the fractions will be released for the 425 version of CC Connected. So they will be available once you have registered and enrolled for the next academic year, you will have access to the digits, naturals, and fractions after about April. So they should go live sometime in April for everybody who is enrolled for next year.
Say May, because my deadline's April, so just in case they have some issues uploading and things, but they're coming soon. We mean it.
Yeah, we just want to be, we're just trying to be very clear that it is for everybody who is enrolled. So, yes, Jess, the charts will be in the companion. What you will see in the companion this year is there will be quite a bit of content that's available that sort of transcends all of the domains. For example, the glossary and different things like that would be sort of across all of those domains. The domain that we will be releasing, but everybody will have access to, is the complex domain. And the way that the companion is set up is that you will click a button to open a digital version of the complex, and you will click on something sort of like I'm sitting next to you, and you point to something on the page and you say, explain this. Not everything is live yet, but you will be able to flip through those books digitally and click on different aspects of those booklets to get more content. And so there will be additional content for the charts, for the frames, for the cover, and for the tops. Generally speaking, the tops of 4. And so there will be additional content for that you will be able to click on and see. And the digital versions will not have the frames or the charts. They will be like the naturals now. They will have that cover, the contribution to the conversation, the 16 lesson pages, and the solutions pages. So you will be able to see what those other pieces look like by looking at the complex booklets in the companion, but they are not going to be printable. There'll be a digital resource. And the print versions are going to be, again, live in April. And I don't know if either of our curriculum assistants want to address the timing of when that is, but that's when the complex print version will be available. And then as you see on that release schedule, next year, digits, integers, fractions, complex, and monomials will be available in print. And then the following year, so April of 2026, April, May-ish of April 2026, we'll have everything through binomials available in print, and then so forth, rolling out over the subsequent 3 years until all of the levels are printed. So Deanna, so review is built in. So obviously, we've talked about the flashcards, and then in those lesson pages, they're going to be doing 2-digit addition. There will be additional things in the careful calculations throughout the booklets, right throughout the year. They're going to be practicing, addition in the context of different concepts. So they're going to be continually repeating and practicing throughout the year. Although it's not perfect, we do have in the companion, there will be an opportunity to see how different weeks sort of build on one another. So how I might take a concept from week 3 and see that again in week 9, or be in week 25 and see these are the weeks that really helped build to this. So we're working on having that resource available as well, so you can see where things review within the year as well as from year to year. And the charts, once you can see the charts are really your full scope. So the math map itself is your brief scope and sequence, where we see the 30 major topics that we're going through every year. And our sequence is our domains, right? So we're going to be working with these different number sets. That is our sequence. Once you have access to seeing those charts, you will really see the full scope of the curriculum, detailed concepts that we're going to be looking at. And again, all of those are touched on each year, just moving from a grammatical, looking at it as familiarity with notation over the course of 13 years, moving towards really becoming familiar with those ideas and building understanding with those ideas from the charts. So those charts are really the things that are going to help you to see the full scope of the curriculum and the sequence throughout the year of instruction. So
something I want to take a minute from your time, Kirsty, to explain this, because people have asked a number of times about review, and yes, we have review, and we have things that you'll recognize as review. But if you think about how math is actually communicated, there's only about 13 operations. And if you look across this math map Kirsty's put in front of you, there's 1, 2, 3, 4, 5, 6 7 kinds of numbers. I just noticed our AC is missing on this one. There's 7 numbers, and all you're ever doing when it comes to calculations is using one of those 13 operations with one of those 7 kinds of numbers. So all you can ever do is review. It's always review of those concepts. The problem is we've just been given thousands of pages over 13 years and maybe more in college, and nobody ever pointed out that, 13 operations sounds like a lot, but there's only 13 of them, and I bet you add, subtract, multiply, and divide you're pretty darn good at, right? So there's only a few other ones for you to learn. And so in one way, that is what the review is recognizing that there's only so much language, just like there's only so many letters in the alphabet, and you're just using them over and over again.
great reminder. Jill, there is not, the digital versions of the curriculum are what you can download and print out, and the companion is where the explanations and extras will be. So the glossary and so forth. So that's a good question. We're both digital. The companion is a digital resource, but it has a lot of extras, and it is not downloadable nor printable, just because that would burn through everybody's paper and not be practical. So, all right. Let me go ahead and introduce us to lesson 10. And so notice in 9, we were talking about straight lines, and we were talking about looking at how do we define a line now in 2D. So does anybody remember how many lines at a time could there be in 1D? Just one, right? There's just one type of line. And how many lines could we have in 2D, do you think?
2.
Well, there are 2. Could we have more than 2?
I think infinite, because you can draw your line with a slope anywhere, right?
Yes, we could have an infinite number of lines in 2D, right? And not just could they change their slope, but they can also change their location in the plane, right? So we can have this infinity of lines. Do we expect lines are going to intersect? Yes, it's probably, if we were to pick 2 random lines, it is probably more likely, right, that they would intersect than that they would not. And so once we've taken a week and we've sort of talked about what a line is in 2D, now we're going to talk about what happens when they intersect, when they cross.
I'm thinking about how Melba answered in such an obvious way, and then it wasn't. And I was thinking about how we framed the question, Kirsty, that if you went from points to lines in 1D to 2D versus going from a line to a plane in 1D and 2D, that's more analogous. Is that correct or not?
Yeah, I think that's a great analogy. Yes. Okay. So let's take a look at this page, and what are some things you see on here that are familiar or unfamiliar?
Angles.
So
The cross,
are angles familiar to you or unfamiliar to you?
familiar.
Okay. Now, to a 6-year-old who's maybe doing this for the first time, would it be a familiar or unfamiliar idea?
Probably not.
They might call it corners.
Mm-hmm. Yeah. I think if you ask them what's familiar, they would say trees and buildings and crosses and shade, lampposts and things, right?
Clock face.
Mm-hmm.
Sometimes it depends too if they're a firstborn. Because, like my youngest knew a lot of words and had seen a lot of pictures and things. I remember with foundations, he was 3. He came running out of the garage one time with a toy rake going, "Mom, Ronald Reagan," from hearing, history sentences. So they might have heard 90 degrees. So when we show, they might say, "Oh, that's where that fits," which I think is so amazing that our younger kids, even before 6, hear some of these conversations, which are just going to make it even easier for them to step into.
Did somebody just say oils?
Mm-hmm.
Yeah. So our 6-year-olds would be familiar with those angled lines.
Mm-hmm.
Great.
I
So
think
good.
it's
So
interesting that we're conditioned to start at the top of the page and think about what's familiar there, but a 6-year-old is not going to start at the top of the page.
Yeah, good point.
and I love the fact that as you're pulling from, hey, they've already heard these things if they're in foundations, or they've already heard these things from their older siblings, and now already they have that opportunity to go, oh, right, to have that dialectic moment where they make a connection, where these things that I've heard, these things that I've sung about, these things that I've said, now I'm starting to put them into their place. Right. And so when we think about the math map, one of the overarching goals of the math map that Lee had was she wanted people to know, where am I? Right. What is the big framework that I can put things in? And it reminds me of when we joined Foundations many years ago, right? And we talked about that pegboard. Did you start by pounding your pegs in, and then you start hanging your knowledge and making the connections? Mm-hmm. Now we see that same thing here happening, that we're helping people to see, here's your pegboard. Mm-hmm. Right now, where do things fit on your pegboard? So it's this idea that Lee has always given us for organizing and arranging our knowledge, and we're just really expanding that and giving you more depth for mathematics. So let me
piggyback on what Karen said, because I thought that was very insightful, Karen. You made me think, all right, if you're that type of child, and there are types of personalities who has to start at the top and go down, and they see that protractor and they don't own one or know what it is, they're immediately frustrated. Versus the child who's learned that paperwork's just fun, and I see things on a page, and they work from the bottom up, and they go, well, I got everything done. Mom, what's a protractor? Right? So things like this, they aren't about teaching math. They're about us learning our children's personalities and what's strong and weak with them, and how to help them overcome those issues too. So the problem is so often we don't give them those kind of challenges or pay attention to it till they're 12, 13, 14, and they're doing a big thing that's hard, instead of taking advantage of these little things that are hard.
I'm going to go ahead to page 2, and just what Jill is talking about, right? That there's some words here that our students may have heard. So let's take a look at the bottom. What are the kinds of angles that may or may not be familiar to our students, and how can we, right, through coloring, how can we help them to become more familiar?
I guess I'm thinking of pies. We could definitely bake some pies and demonstrate these angles.
You can
Love
play
that.
I want to come to her homeschool.
YMCA.
Or even pizzas. We do lots of pizzas at our group, and just they all love pizza. So
What kind of a slice of pizza or pie would you want if you were really hungry?
An obtuse.
If you're not super hungry, or maybe there's a lot of people that need to share, what kind of angle would you want? Cute, right? So we can help our students to start getting a sense for these, right? Even though we're coloring, right? Here's some words where it says to read the words aloud. Here's some words that we're going to read aloud, and we can help them to start getting just that fundamental idea of what those things are.
Even the word acute, you know, if you have a sharp pain, the doctor tells me it's an acute pain, and now you know why.
All right. On page 3, right? Does this start to look a little bit more challenging, math-wise, computation-wise? Are you? How many of you would be tempted to jump straight to the middle of the page and do those calculations?
Yep, absolutely. Yep.
And how many older siblings would tell the younger siblings, "Ooh, this is hard."
So here's one of the things, right, that we tend to think when we say math, we tend to think computation, right? And one of the things that the math map is really helping to do is to broaden our view of math, right? And to see math as more than just computation and calculation. That's an important mathematical skill, right? But it's only a small portion of this page, right? And so the notation, so doing those the matching at the top where we're looking at notation, looking at what it means for angles to be complementary from a figurative way, right? Using images instead of just the calculation, talking about what it means for things to be congruent, right? So we're going to there's a lot here that we can talk through with our students beyond the calculation. And I just want to encourage all of us because one of the things to do with the math map is really broaden everybody's invitation to a math conversation that transcends calculation, right? Not that we want to diminish the importance of calculation, but recognize that calculation is a portion of, not all of, mathematics. And then page 4, here we go. And let's take a minute and talk about what's familiar and what's unfamiliar on this. And go back to where we talked about how many different lines we could have and how likely it is that they intersect, right? What do we see on this page here?
We see that three lines make a triangle.
Good.
And we see I think there's a lot of words, oblique and perpendicular, that are going to be new.
So Kathy, here's a question for you. How do you know what a triangle is? Because we haven't taught that yet in the math map.
Right.
But what did you do with your littlest ones?
We already showed them shapes. We've taught, you teach your 2- and 3-year-old shapes probably.
So is 5 or 6 when you start with the math map, is that when you start your child's math education?
No, much earlier, because you're always counting things and looking for patterns.
Excellent. So we do have a great resource, right? The Scribblers is a great resource for those younger families that are going to help point them in the direction of what we're doing in the math map. But I love that you just said that, Kathy, right? Like my 2-year-old, I'm teaching them what a triangle is, right? Their toys have all these different shapes that I'm naming with them. And so there's a lot of things that we're going to encounter here that we're teaching our students or our children just naturally, right, as part of doing life with them. And so that's, I want to encourage us.
And also remember, at 5 and 6, you're not really teaching math. You're preparing their bodies to learn math.
Can I ask a question? Is that why it's quiet?
Ask away.
Yeah. Okay. I am wondering about the frames and how we would use those at home. Is that a part of this discussion or not?
You know, we're running out of time, but that's come up a couple of times. Nicole, Kirsty, why don't we put a slide in at the beginning where it says questions, and let's say frames, and let's answer the question then for frames at home, so we can give it some good information. Thanks, Nicole. Is that okay? No, Lee, I want it now.
All right, I have made a note, Nicole, that next week I will address that specifically for you, what that will look like at home. One thing that I did notice that there was a question about the importance of having the complex materials for class. And so I just wanted to address that really quick, that there's a lot of people who have a math curriculum that they like or they're confident with, and they're kind of like, well, why do I have to have this? And I'm guessing most of you are like me, that the reason we joined CC was for the community. And I was always drawn to the fact that Lee talked about her older students really needing that opportunity to have a great conversation with other students in order for them to become truly rhetorical, and that they needed it to be outside of their family, right? If we just have our conversations in our little bubble of our family, we don't have that iron sharpening iron and challenge to really become rhetorical and know why we believe what we believe and how to communicate that. And so as I saw Lee talking about that with her oldest sons and why she developed classical conversations, right, I wanted that for my family too. I wanted my children to have that opportunity to have that conversation. And as I've seen them move through challenge, the best conversations that they have are the conversations where everything is in common, where they've done the same Latin lessons, where they've read the same books, whether they've wrestled right over drawing the same maps each week. That when they've had that common experience at home, those classroom experiences, those in-community experiences and conversations are so much deeper. Unfortunately, that has probably been the weakest place for my kids. Math is in math, because the way that even Saxon is lined up, if you're off just by a few lessons, right, right, I've tutored challenge, and so I know that in 1 week those 4 lessons can be widely different topics. And so if my students are off just by a few weeks, they can be studying really different things each week. And we can still have a good conversation about math, but it's not as good as it could be. And so by having everybody having the same materials and the same curriculum, we really believe you're going to have better conversations. And one of the reasons that we created the math map the way that we did is for those conversations to happen both at home and in community, because we can all be talking about intersected lines, but my youngest students, or depending on the level of my students, where they are in their math journey, right? We can all be talking about intersected lines, but be doing it at the level that we're ready for. And so now we can all have this common conversation and community, and it can be a really beautiful thing, even if my students aren't necessarily quite at the same point developmentally. And so that's why it's so important for everybody in Challenge A next year to get the most out of the experience of Challenge A, to get the most out of being in CC and get the most out of those conversations. Finally, we can offer you the curriculum where you can tailor that to meet the needs of your student while still being in the same topic as everybody else, still looking at the same grammar as everybody else, still wrestling with the same questions as everybody else, but where your child needs to be.
To me, I like to liken it to at a Bible study. I might have an ESV version and someone else has an NIV version, but we're reading the same passage, and our additional comments that we learned from our specific reading, hopefully we'll make it so that maybe it gets enhanced, but it might make it so that we just ask a better question and go, why does it say it that way? And now I need to go back to the original Greek and Hebrew, and it just spurs one another on. It doesn't make the conversation worse, it makes it better.
Can I ask a question in relation to that?
Mm-hmm.
Can you give us a little bit of rhetoric around the idea that it takes away from letting kids move slowly or quicker because they all have to be on the same subject? Like if I wanted to work through this in 40 weeks instead of 30, then I wouldn't be on the same week. And so, or if I, this idea that all of my kids would be doing integers, well, what if it took my kids longer to get through one of those previous weeks? Can you talk through how we would work that to where we are on the same week, and then how we would respond to others who might have that concern?
Yeah, so here's the thing. There's no way for all 120,000 children enrolled in classical conversations to be on the same lesson and the same topic, because different churches start at different times, right? So just like we as having to train and support you have to be a little bit ahead of the game in order to make sure the conversations that we're having as leaders are the same, but we know you may not actually tutor that week, that subject. You might be doing it 2 weeks out or 3 weeks out. I cannot control time and space. And it turns out neither can you in your own family, that you're going to have children in the younger ages in particular who may be they just go, I love tracing and coloring and copying, and they race through the lessons and they're done in half a year, while your older child working, who's actually doing the calculations, isn't on the same page. It's okay. Children are going to be children, but in this case, you as a parent have a plan. And yes, your children may be ahead or behind you, but you have a plan. And for those of us who are struggling with anything, having a plan just helps us to do better, right? It's kind of like you don't say, I'm going to lose 100 pounds. You say, I'm going to take a walk tomorrow, and I'm going to take a walk the next day, and I'm going to take a walk the next day. So we've got you set up for that. How it varies among your actual life, Nicole, it's going to be all over the place. But now when you show up at Challenge, or to your community, at least 2 or 3 other people probably have the same questions you do and are doing the same problems you're doing. Even if your children aren't and they aren't, the adults in the community will be working together.
Lee, can I also address the fact that while what Lee said, we may be, all your family may not be together, or your community may not be together, but also I always want to come back to something that Lee says, is that we are conditioned to start at page 1 in a book and move through to page end. And we have to get through every single page. And one of the things that I think we're trying to maybe change with the math map is that there are so many ways that you can tailor that week to meet the needs of your student. So instead of thinking about being advanced, meaning I went faster and I'm in a later book, or I'm slower and so I haven't got there yet, instead of thinking I have to get the entire book done, being able to take that book and say, okay, well, maybe we're only going to do 8 pages, right? And so we're going to do 2 pages a day instead of 4 pages a day. And we're going to get through half of the booklet each week. And then we're going to move on. And then we're going to come back on our breaks and we're going to look at those pages that we missed.
Or the next year.
Or the next year, I'm going to come back and look at those pages that I missed. That I think one of the goals that I've really appreciated hearing Lee repeatedly say, right? You guys have heard me repeat this because I've heard it from Lee, and I just think it's so great, is to use the book and not to let the book use you. And so we have really tried to make the math map be a very tailorable experience. And we're trying to help equip the Challenge A tutors to really help parents at home meet the needs of their students by tailoring it. We're including information in the companion about how to tailor the curriculum, that you can take this now and say, okay, I don't have to start on page 1 and go to page 16 and do this on the I pages, right? That you can say, okay, this is how this fits my family this week, or this is how this fits my family, right, this semester. And you can adjust. So that way I could keep all my kids on the same week, but maybe is doing all 16 pages. Maybe the other one's just playing the games, right? Because I can meet my students and their needs where they are. So, because Lee's heart has always been, right, to equip parents to teach math. And I think that that's what she's creating here, is a use to teach home.
We'll talk more, Nicole, next week. You asked really good questions. Thank you.
All right, well, we are out of time. Thank you so much for being here with us today, and we'll look forward to next week, and certainly we'll take a look at some of those frames, so you know when we talk about those frames what those look like and how we could use those.
Thank you, everyone. Thank you, Kirsty, for leading us. Bye.